Hey guys, welcome to my video series on graphing functions by hand. In this video, I'm going to show you the steps you need to take to easily sketch a Truncus function, and then go through 4 different examples. Starting by a quick theory, the basic Truncus function has the rule y is equal to 1 on x squared, and its graph is going to look something like this. Notice the graph lies above the x-axis in the first and the second quadrant. For a negative Truncus function, this is going to be minus 1 on x squared, and its graph is going to look something like this, where the graph lies below the x-axis in the third and the fourth quadrant. The graph of a Truncus function has both a vertical asymptote and a horizontal asymptote, and we show this by dotted lines. And for the parent function, this is going to be the lines x is equal to 0 and y is equal to 0. The general rule for a Truncus function can be written as y is equal to a on x minus h all squared and then plus k, where the value of a will affect the dilation of the graph, the value of h will determine the vertical asymptote, where it is, and the value of k will tell us where the horizontal asymptote is. And here are the 4 steps that you need to take when sketching a Truncus function. It's identical to the steps of sketching a hyperbola graph. The first step is to determine whether it's going to be a positive or a negative Truncus, and we do this by checking whether there's a negative sign in front of the fraction part of the rule or not. The second step is to work out the equation of the vertical asymptote and the horizontal asymptote, which I'll show you how in the examples. The third step is to find the x and y intercepts, if there are going to be any. And the last step is to label these features on the axis and then sketch the graph. And that's pretty much it for the basics. So let's jump into the examples. Sketch each of the following, clearly showing the position of the asymptotes and the intercepts with the axes. Part A, y is equal to 2 on x squared. Step 1. We need to determine whether this is going to be a positive or a negative Truncus. And looking at the rule, this is clearly a positive. And so this tells us that the graph is going to lie in the first and in the second quadrant. Now, just as an important note, the quadrants are not determined by the x and y axes. It's determined by the location of the vertical and the horizontal asymptotes. And so whenever you have asymptotes that are not the lines x is equal to 0 and y is equal to 0, then you need to treat the asymptotes as the new set of axes. You'll see what I mean when we do parts B, C and D. Alright, for step 2, now we need to work out the equation of the vertical asymptote and the horizontal asymptote. For the vertical asymptote, we let the denominator equal 0 and then solve for x. And so for this part, we're going to let x squared equal 0 and solve for x. Taking the square root of both sides, we're going to get x is equal to 0. And so therefore, the equation of the vertical asymptote is going to be x is equal to 0. For the horizontal asymptote, this is going to be the constant that is added or subtracted to the fraction part of the rule. And since there's no constants, then this is going to be the line y is equal to 0. And so the horizontal asymptote is going to be the line y is equal to 0. Step 3. We need to work out the x and y intercepts. Now, because the vertical asymptote is the line x is equal to 0 and the horizontal asymptote is the line y is equal to 0, and we know that graphs cannot cross these asymptotes, then this means that there's not going to be any x or y intercepts. And so for this question, there's going to be no intercepts. And now for the final step, we just need to label the asymptotes on the axes and then sketch the graph. And so we draw the axes and then label the equation of the asymptotes and then sketch the graph, making sure that the curve approaches the asymptotes and does not touch or cross the asymptotes. Part B, y is equal to 1 minus 4 on x squared. And so for step 1, we need to determine whether this is a positive or a negative Truncus. And so looking at the rule, we've got a negative in front of the fraction part, and so we know that this is going to be a negative Truncus. And so its graph is going to be in the third quadrant and in the fourth quadrant. For step 2, we need to work out the vertical and the horizontal asymptote. For the vertical asymptote, we let the denominator equal 0 and then solve for x. And so this is just going to be x is equal to 0. And so the equation of the vertical asymptote is going to be the line x is equal to 0. The horizontal asymptote is going to be the constant that's added or subtracted to the fraction part, and this is going to be the line y is equal to 1. And so the horizontal asymptote is going to be y is equal to 1. Step 3. we need to work out the x and y intercepts. Now, because the vertical asymptote is the line x is equal to 0, this means that there's not going to be any y-intercept. And so we only need to work out the x-intercept. To work out the x-intercept, we let y is equal to 0 and then solve for x. And so we're going to get 1 minus 4 over x squared is equal to 0. Moving the fraction part to the right-hand side, we're going to get 1 is equal to 4 on x squared. Multiplying both sides by x squared, we're going to get x squared is equal to 4. Solving for x, x is going to equal plus or minus 2. And so the x-intercept is going to be plus or minus 2. And now for the last part, we need to label all this on the axes and then sketch the graph. And so starting with the axes, we label the equation of the asymptotes and then marking the x-intercepts and then sketch the graph. Now notice the third and the fourth quadrant is in relation to the location of the asymptotes, and it's not just the x and y axes. Part C, y is equal to 2 on x minus 1 squared minus 2. And so for step 1, this is going to be a positive truncus. And so its graph is going to be in the first and in the second quadrant. Step 2, for the vertical asymptote, we let x minus 1 squared equal 0, which means x minus 1 is equal to 0, and so x is going to be 1. And so the vertical asymptote is going to be the line x is equal to 1. The horizontal asymptote is going to be the line y is equal to minus 2. And now we need to work out the x and y intercepts. For the y-intercept, we let x is equal to 0 and then solve for y. And so this is going to be y is equal to 2 over 0 minus 1, which is minus 1, and then all squared minus 2. Minus 1 squared is just 1, and so this is going to be 2 on 1, which is 2 minus 2, and so this is just going to be 0. And so the y-intercept is going to be 0. For the x-intercept, we let y is equal to 0 and then solve for x. And so we're going to get 2 over x minus 1 squared minus 2 is equal to 0. Taking minus 2 to the right hand side, we're going to get 2 over x minus 1 squared is equal to 2. Multiplying both sides by x minus 1 squared, we're going to get 2 is equal to 2 times x minus 1 squared. Dividing both sides by 2, we're going to get 1 is equal to x minus 1 squared. Taking the square root of both sides, this is going to be plus or minus 1 is equal to x minus 1. And so solving for x, x is going to be 0 or x is going to equal to 2. And so the x-intercepts are going to be at 0 and when x is equal to 2. And now for the final step, we label all these information on the axes and then sketch the graph. And so on the axes, we label the equation of the vertical and the horizontal asymptotes. We're marking the x-intercepts and the y-intercepts, and then we sketch the graph. And again, notice that the first and the second quadrant is in relation to the location of the asymptotes. Part D, y is equal to 4 minus 2 on 3 plus x all squared. And for step 1, this is going to be a negative truncus. And so we know its graph is going to be in the third and in the fourth quadrant. For the vertical asymptote, we let 3 plus x all squared equals 0 and then solve for x. And so 3 plus x is going to be 0, and so x is going to be minus 3. And so the vertical asymptote is going to have the equation x is equal to minus 3. The horizontal asymptote is going to be the line y is equal to 4. And now we need to work out the x and y intercepts. And so for the y-intercept, we let x is equal to 0 and then solve for y. And so we're going to get y is equal to 4 minus 2 over 3 plus 0 and then all squared, which is going to be 3 squared. This is going to be 4 minus 2 on 9. To work this out, if we put this on 1, then we can write this as everything on 9, and then 4 times 9 is 36, and then minus 2 times 1, which is 2. And so this is going to be 34 on 9, which is going to be a little bit more than 3.4. And now for the x-intercept, we let y is equal to 0 and then solve for x. And so we're going to get 4 minus 2 over 3 plus x all squared is equal to 0. Moving the fraction to the right hand side, 4 is going to equal 2 over 3 plus x all squared. multiplying both sides by 3 plus x all squared, we're going to get 4 times 3 plus x all squared is equal to 2. Dividing both sides by 4, this is going to be 3 plus x all squared is equal to 1 on 2. Taking the square root of both sides, we're going to get 3 plus x is equal to plus or minus 1 on the square root of 2. And so x is going to equal plus or minus 1 on root 2 minus 3. And now we've got all the information that we need. All we need to do is label these on the axes and then sketch the graph. So on the axes, we draw dotted lines and write the equations of the asymptotes, remarking the x and y intercepts, and then sketching the graph in the third and the fourth quadrant. Which brings us to the end of this video. Now I hope you found it useful, and if you did, give it a thumbs up and share it with your friends. If you have any questions, comment below. And if you want to try an exam question where you needed to know how to sketch a Truncus function, then log into the Maths Methods Club and see if you can do the 2019 Exam 1 question 5. To get to that, just go to the year and then select 2019. And then from the question number, select question 5. Try this question and see if you can get full marks. Good luck, and I'll see you guys in the next video.